Okay, I'm going to start with example 14 and 15 in case you're using this video to help you with your project first, and then I'm going to go up and do the rest that we haven't tackled from in class. This is your test review for the upcoming transportation unit test. Okay, you are going to need a Desmos tab and possibly some scratch paper, so go ahead and get that handy if you need it. All right, so in your project and coming up on the upcoming test, we might ask you just a common question. And in general, we try to think of breaking down your budget into what percentages should be towards each item. And so, a general rule of thumb is to keep your car payment less than 10% of your monthly pay. So, if your gross annual income is 46,500, what is the maximum monthly car payment you should shoot for? So, we're going to go over here and put that annual figure of 46,500. We're going to divide it by 12, and that gives us 3875. So let's do that math. That is your monthly gross pay. So what my car payment should be 10% of that. So 0.1 of 3875 is 387.50. So just to give us an idea for budgeting purposes, you're going to take your annual income, you're going to divide it by 12. You're then going to use that 10% of that is going to be your budget for your monthly payment. Do people spend more than that on car payments? Heck yes, they do. It's just a rule of thumb that if you are eventually trying to buy a house or own property someday, you're going to want to keep things like a car payment and credit card payments down. Okay, let's go down to example 15 now. Let's actually calculate a car payment. And by the way, here's the monthly payment formula in case you need it for the project. So this vehicle is a $37,999 price. Calculate the following. For sales tax, we're going to use 8.75%. So first of all, we take the 37,999 and we're going to multiply it by 0.0875. There's my 8.75. So I'm going to get 3324.91 as my sales tax. Okay, then total cost of the vehicle, including the tax, we do the 37,999 plus that number I just got, and let's see what it gives us. And I'm getting 41,323. So this is the actual amount you're going to finance. You got to include the tax in there. Okay, so now what's the monthly payment on this vehicle at 5.99 on a 5-year loan? And we are going to be doing a 5-year loan across the board for the project. So here I go, principal. This is the amount I'm financing. This is my new principal amount. So this principal times the rate over 12, 0.0599 divided by 12. Remember, you're using different rates for the project, so be careful with that. 0.0599 divided by 12 again. And I just noticed I forgot the 1. So sorry, I'm following this formula right here, so don't forget the 1. 1 plus. So principal times the rate over 12 times 1 plus the rate over 12, all to the power of 12 times the time. 12 times 5 in this case, it's a 5-year loan, t equals 5. We could also just put to the power of 60. All right, we want that whole thing to be a numerator, so you arrow out and divide by on Desmos, and then we're going to do the same thing on the bottom. Now, some people get smart here and they go, oh, I could just copy and paste this. Or just type it again, parentheses 1 plus 0.05599 over 12 to the power of, and then don't forget the minus 1. Oops. Down here, people, minus 1. Okay, so my car payment is $798.71. Right. Finally, what is the total interest paid? So if I know that I am paying $7.98 a month, and I want to see how much I'm paying after 5 years, I'm going to go $7.98 times 60 months to see how much I'm really paying for the car. And I'm getting $47,922.60. Now, what that is called the sum of the monthly payments. It's all the payments you make in all the 5 years. So to get the interest paid, you're going to subtract 47,922.60 minus the original price of the car, 37,999. So to get the interest paid, we do the sum of the monthly payments minus the original price of the car. And I'm getting 9,923.60. Don't know what that is. So we're going to go 9,923.60. Okay, how'd you do? Where is this from? How are we supposed to know this? This was back from the credit chapter from first semester, plugging into this formula and then getting the sum of the monthly payments and then subtracting to get the interest paid. So this is back from chapter 3. Okay, and then these answers I typed up here, but I'll put them down here. Here's your tax. Here's your new price of the vehicle. And here's your monthly payment. Okay, and if you're sitting here thinking $798, it's a huge card payment. Exactly. Probably don't want to be shopping for that expensive of a car unless you have a really high income. 41,323. Sorry, I'm going back to the original price is what I meant to do. Clear this out. 37,999 divided by 60 months. I mean, just the price of the car alone with no interest is already $633 a month. Then plus there's sales tax, plus there's interest. It just really drives that payment up. So keep that in mind if you're trying to keep your car payment down. Don't go looking for a $40,000 car and make sure your interest rate is much cheaper, etc. Okay, those are the two calculations you're going to need to do on the project. So that's how we do those. Now let's go back up to the other ones that we didn't get a chance to finish. So first, looking at how our cars depreciate. So if a car originally sold for this, now remember on this lesson, I taught you guys how to go up to insert equation, and then you typed it y equals whatever that starting value is, 1 minus the rate of depreciation to the power of x. And in this problem, we're given these inputs, and we're going to solve to find how much it's worth after 7 years. So here we go. Starting value, 33,000. Depreciates at a rate of 6 1/4. Remember that we want the decimal of that, 0.625. 0.0625, so move that decimal twice. And then to the power, the time is 7 years. Okay, so this is what we're going to be plugging into Desmos right now in order to find our output. So 33,000 times 1 minus 0.0625 to the power of 7. So the vehicle is worth $21,004.53. After 7 years. Okay, so we're just plugging into this exponential formula, exponential depreciation formula from Math 1. And those are all the parts that go into it. Now, what if we wanted to solve for a different variable in that same equation? I'm going to go up and copy it, save me typing time, and paste it. And this time, let's see what they gave us. They said a 4-year-old car was purchased for $11,200. So this time they are giving us an output. And they told us that it's the power of 4 years. But it says that if the new car was, when the car was new, it sold for 21, what's the rate of depreciation? All right, so first I'm going to take and divide. So insert equation. I'm going to do the 11,200 divided by, oh, actually I want to do the little fraction thing up here, sorry. Fraction 11,200, and then our denominator is going to be dividing by 21. Oops. And this is equal to 1 minus the rate to the power of 4 somehow I got out of the equation. Hang on. All right, then we have to fourth root both sides of this. So we're going to take the fourth root of the left-hand side, and then that's going to leave us 1 minus r on the right. So let's go take the fourth root of that fraction. So see this little thing down here, nth root? You're going to tell it the fourth root of 11,200 divided by 21,000. And that's a 0.85 right over here. See it? All right, and so if we're trying to solve over here for this, we can minus the 1 from the 0.85. So we're going to do 0.85 minus 1, and that's going to equal negative r. And so over here we go 0.85 minus 1 is negative 0.15 is equal to negative r. So then we know that r is equal to 0.15, positive 0.15. It's like you're dividing both sides by a negative 1. So we just got that the rate of depreciation is 15%. Okay, now this is an output problem where we had to take the fourth root. Am I going to make you do this on the test? No. Am I going to make you do this one up here on the test? Yes. So just be prepared that taking the fourth root of something, we might be a little rusty at that, and that's why I'm not putting that one on the test. Okay, last section. We did this one very brief, just in one day. What is the approximate braking distance for a car traveling 85 miles per hour? Write the proportion and solve. Remember, this does not include the reaction time of 1 second per mile per hour. The general formula for the braking distance is this. So notice the 4 expressions below are equivalent. So what is the approximate braking distance where S is equal to 85? So plugging in S to this equation, S squared over 20. I'm going to put 85 squared divided by 20. And it'll look better if we do the insert equation. Do the little fraction, and we do 85 squared divided by 20. All right, let's go calculate it. It's telling us 361.25. So what did we just find? We found the braking distance for a car that's traveling 85 miles per hour. You would need 361.25 feet to stop the car. Remember, this is not including your reaction time. Your reaction time varied. You need about 1 second per mile per hour. So this is a lot of feet that your car can travel when you hit the brakes, another 360 feet. So keep that in mind. Always travel a really far, safe distance between other vehicles. The reaction time and distance. We learned in this chapter that the average person's reaction time ranges from 0.75 to 1.5. If a conservative rule of thumb would be to say that a car travels about 1 foot for each mile per hour of speed, that means that a car traveling 48 has a reaction distance of 48. So what would the reaction distance be for a car traveling 77? The reaction distance would be 77. So picture this. From when you notice something's going wrong, and then your foot transfers from the gas over to the brake, you travel another 77 feet while that's happening. Then once you hit the brake, you could travel another 300 feet to stop your car, depending on the speed you're going. You need a lot of space to get yourself not in an accident. So real life reminder, the rule of thumb is to maintain at least a 3 to 4 second following distance, giving you time to react and avoid a potentially dangerous situation. You can calculate this by using a fixed object like a pole or an overpass to determine how far in front of you the car is. Let's be safe, people. No need to rush, no need to tailgate people. Stay far enough behind other people so you don't get in an accident, okay? That's the end of our review. We're all done. How'd you do?